Hello everyone, my name is Oyewale Peter, and in this tutorial we're going to discuss complex numbers. So for these aspects, we're going to use this particular subtopic. So let me place the topic as complex numbers. Then I'll use these subtopics for the essence of this tutorial video. So subtopics that will be treated in this video. The first one, we're going to treat the introduction to complex numbers. Then we're also going to treat the symbol I, the symbol I. Then next, we're going to treat the powers of I, the powers of I. Next, we're also going to treat equality in complex numbers. Equality in complex numbers. Okay, so without wasting much time, I'm going to start with introduction to complex numbers. So let's start from the first one, which is a form of introduction. A, introduction to complex numbers. Now, one of the first things that we need to know is that a complex number is a number that actually aligns with the form a plus bi, so which can be regarded as the general form of a complex number. So this is it, a plus bi. This a represents the real part, while the other side represents the imaginary part. So what it means is that every complex number has a real part, while every complex number also has an imaginary part. For example, let's assume that you're trying to get the solution of the quadratic equation 5x squared minus 6x plus 5 is equal to 0. Now we know that if you are to use a formula method to solve this, our formula method states that our x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Now what this means is that our a from this quadratic equation, our a is equivalent to 5, our b is equivalent to minus 6, our c is equivalent to 5. So it means that x will give us minus b, that's minus 6, plus or minus square root of b squared, which is minus 6 raised to power of 2, minus 4 times our a, which is 5, times our c, which is also 5. Now this is divided by 2 times a, which is 2 times 5. So here our x is going to give us minus times minus 6 is plus 6, plus or minus square root of 36, minus 6 times minus 6 will give us 36. So minus 4 times 5, that is minus 20. Minus 20 times 5, that'll give us minus 100. Divided by 2 times 5, which will give us 10. Now from here, it can be noted that our x will give us 6 plus or minus square root of 36 minus 100 will give us minus 64. Everything divided by 10. Now what this means is that our x will give us 6 plus or minus. Now, basically, we know that square root of 64 is 8, but square root of minus 64 is not going to give you a real number. Now, this is where the basic idea of complex number comes into play. Now, we can say that square root of minus 64 is the same thing as square root of 64 times square root of minus 1 from laws of indices. Or even before getting to this, you can initially say that square root of minus 64 is equal to square root of 64 times square root of minus 1. Okay, basically, that is not actually what I wanted to represent. I wanted to represent it first as a combined square root. So square root of minus 64 is equal to square root of 64 times minus 1. So 64 times minus 1 will give us minus 64. So it means this and this are still the same thing. Now we know that from laws of sorts, when we have square root of a times square root of b, it is the same thing as square root of ab. So from here, since we have defined square root of minus 64 to be the same thing as square root of 64 times square root of minus 1, it means square root of minus 64 is going to give us square root of 64 is 8. Now, square root of minus 1, we represent it using I. And that is where this symbol comes into play, which represents an imaginary number. This is a number you can't see on the number line. So basically, it means that square root of minus 64 is going to give us 8i. Now, instead of writing square root of minus 64 here, we represent it as 8i divided by 10. So it means that our x is equal to 6 plus 8i divided by 10, or 6 minus 8i divided by 10. Now you can still decide to simplify this further. Here, our x is going to give us, if we divide through by 2, or let's factorize 2 from the numerator, this will be 2 into 3 plus 4i. 10 is the same thing as 2 times 5, or 2 into 3 minus 4i. 10 is still also the same thing as 2 times 5. So our x here is going to give us 2 cancel 2. This 3 plus 4i over 5, or 3 minus 4i over 5. So it means our x is 3 over 5 plus 4 over 5i, or 3 over 5 minus 4 over 5i. So if you relate this back to what we have here, which is the introduction, that is, every complex number is going to have a real part and an imaginary part. Now, in that question, if we take one of the roots, which is x was equal to 3 over 5 plus 4 over 5i, it means that the real part in this root is 3 over 5, while the imaginary part is 4 over 5. So basically, that's a basic concept of the introduction to complex number. Now, from the introduction, we have already ventured into the symbol I, which has also been discussed in the introduction. So now, basically, we are going to go to the powers of I. So I'm just going to represent that as C. C, the powers of I. Now, the powers of I is actually very simple, and we are going to consider the theory of positive integer numbers, and we're also going to consider the theory of negative integer numbers. Now, what do I mean by that? It means that we have two major divisions here. The first one we're going to see is the positive, the positive integer numbers. What do we mean by positive integer numbers? For example, 1, 2, 3, 4, and so on. So when I is raised to the power of these numbers, it has an important value, or let me say it has important results as it keeps on increasing. So now, what if those powers are now raised to a negative integer? So let's put the second one as the negative, the negative integer numbers. And the negative integer numbers, for example, we're going to have -1, -2, and it keeps on going. So let's start from the positive integer numbers in terms of power. Now already we have defined that our I is equal to square root of -1. Basically, mathematically from here, if we square both sides, it means that I raised to the power of 2 will give us square root of -1 raised to the power of 2. Therefore, I square, the square will cancel the square root, will now give us -1. So here, the first thing that we have here is that our I is equal to square root of -1. Our I square, we have derived it to be -1. Now let's say I raised to power 3. Now, you know that from laws of indices, a raised to power b times a raised to power c is going to give us a raised to power b plus c. Let me clean that. A raised to power b plus c. Now, if we have x raised to power 3, x raised to power 3 is the same thing as x squared times x. Why is x raised to power 3 the same thing as x squared times x? Because x raised to power 3 is x times x times x. So if we combine two of these x, it gives us x squared times x. It means that x raised to power 4 is x raised to power 3 times x, and so on. Now, how am I now bringing the application into this? What it means here is that I raised to power 3 is the same thing as I square times I. So it means that I raised to power 3 will give us our I square, we have gotten it to be -1. This -1 times I. It means I raised to power 3 will give us minus I. So here we can put that I raised to power 3 will give us minus I. Now let's also say I raised to power 4. Now, taking a look at this, seeing how you can easily combine I raised to power 4 with our previous, because we know I squared to be equal to -1. So we can basically just say that I raised to power 4 is I raised to power 2 times I raised to power 2. It means I raised to power 4 will give us I raised to power 2 is -1 times -1. Our I raised to power 4 is going to give us +1. So I raised to power 4 will give us +1. So basically, what we're going to be doing here is that uh, you are going to be relating any number that you have with respect to the initial values, or let me say the initial powers of I that we have. For example, let's say we are looking for an expression for I raised to power 11. Now, I raised to power 11, I can decide to say that I raised to power 11 is the same thing as I raised to power 8 times I raised to power 3. It's not compulsory you use this, but I know that 8 plus 3 will give us 11. I can decide to solve this further and say that I raised to power 8 is I raised to power 2 raised to power 4 times I raised to power 3 is I raised to power 2 times I. So here, I raised power 2 is minus 1 raised power 4. I raised power 2 is minus 1 times I. Minus 1 raised power 4 will give us 1 times minus 1 times I. It means that I raised power 11 is going to give us what? Minus I. So from here we have gotten I raised power, okay, that's I raised power 11, I raised power 4. We have gotten I, we have gotten I raised power 11 to be equal to minus I. So for any power of I that you are given, just look for uh how you can relate it very easily to your I square. Most times if you are given an odd number, the number before the odd number is going to be an even number. So you can always express every even number in terms of I raised power 2. So for example, let's say you have I raised power 99. I raised power 99 is the same thing as I raised power 98 times I raised power 1. So I raised power 98 is I raised power 2, everything raised to power 49 times I. So with this, you'll be able to get or break down your powers of I depending on what you are being given. So now, for the second part, which is the negative integer numbers. For the negative integer numbers, we are going to use the concept of a reciprocal. Now, let's take it in this form. We are still going to use what we know. We know that I is equal to square root of minus 1. And we know that I square is going to give us 1. So basically here, if I decide to divide both sides by I, that is, this is my left hand side and this is my right hand side. If I divide my left hand side by I, this will be I square over I is equal to 1 over I. Now, I in I square is going to give us I. Here, we are left with, oh, sorry, I square is equal to minus 1. Oh, that was a mistake. I square is equal to minus 1. So here we're left with minus 1 over I. Now, minus 1 over I is the same thing as minus 1 times 1 over I. So it means our I will give us minus 1 times 1 over I is I raised to power minus 1. So basically, if we multiply both sides by minus here, minus 1 times I will give us minus 1 times minus 1 times I raised to power minus 1. Let me illustrate that properly. Times I raised to power minus 1. Okay, so what it means here is that minus 1 times I is minus I is equal to minus 1 times 1, that is 1, times I raised to power minus 1. So what it means here is that I raised to power minus 1 is equivalent to minus I. That's the first negative integer power number of I. Now, let's assume that we want to find an expression for I raised to power of minus 2. Now, we know that I raised to power minus 2 is the same thing as I raised to power 2, everything raised to power minus 1. So when 2 multiplies minus 1, you get minus 2. So what it means here is that I raised to power of minus 2 will give us I square is what? Minus 1 raised to power minus 1. So I raised to power minus 2 will give us minus 1 raised to power minus 1 will still give us what? Minus 1, because minus 1 raised to power minus 1 is the same thing as 1 over minus 1. That is, you're finding the reciprocal of minus 1, which will still give you minus 1. So here we can decide to say that our I raised to power minus 1 gave us minus I. Let me represent my I well. Our I raised to power minus 2 gave us minus 1. So let me just prove for I raised power 3. I raised power 3 is going to give us I raised power minus 2 times I raised power minus 1. So that is I raised power minus 3. Minus 2 plus minus 1 will give us minus 3. So here, I raised power minus 3 will give us I raised power minus 2 is minus 1 times I raised power minus 1, which is minus I. So our I raised power minus 3 is going to give us what? Plus 1I. Plus 1I. So here we can write I raised power minus 3 will give us I. So here also it also follows the same concept. No matter what the power is, look for how you're going to relate it back to the very simplest basis of the powers so that you'll be able to break it down. So that is actually what we have on the positive and the negative integer numbers when we are dealing with complex numbers. So if I'm now going, let me check the schedule that I gave initially. Okay, introduction to complex number. That's what we discussed first. The symbol I, the powers of I. So now equality in complex number. Now, before we take equality in complex number, of course, I've given you that the general form of a complex number is a plus bi, and a represents the real part, b represents the imaginary part. So you should also know that real numbers are any number that is positive or negative, but not imaginary. For example, real numbers can include, let's say, 4 over 3, let's say 0, let's say minus 8. Those are numbers you can find on the number line. But when you're discussing of the word complex, it means something that is a mixture of some certain elements. So that's why you're saying the general form is a mixture of a real number and an imaginary number. That's what now makes it what's complex. So you can see the difference between a complex number and an imaginary number. So a complex number is made up of two things, which it has a real part and an imaginary part. Why the imaginary number itself is I is equal to square root of minus 1. So now going back to the equality, and sometimes let's say you can have questions and they will put like this. Let's say you are told to find RE of 2 plus I RE of 2 plus I3. What this question is just telling you to do is that what is the real part of this complex number? The answer is going to give you what? 2. So the real part is A. So it means, as a general formula, RE of A plus IB is going to give us what? A. So, and also you can be told to find IM of 2 plus I3. IM of 2 plus I3 is going to give us what? 3. That is, the imaginary part is what? 3. So IM of the general form, A plus IB, is going to give us what? B. So, and also you take this B with reference to the sign that you have here. It's because we have A plus IB, that is why we're having plus B here. As when we have 2 minus I3, it means our B will give us minus 3. So now, before we dive into the equality in complex number, we must understand the basic arithmetic operations that connect complex numbers with each other. The same way we can add, subtract, multiply, and divide real numbers, we can also do that when it comes to complex number. So, but in this particular tutorial, I'm going to talk on addition and subtraction. Then multiplication and division is what we're going to use to commence in the next tutorial video. So after discussing on addition and subtraction, then I'll talk on equality in complex numbers. So let me first discuss on addition and subtraction. let's consider two complex numbers. Um, let's say our first complex number is, let me represent as Z1. Our Z1 is equal to 6 plus 5i. And let's say our Z2 is equal to 3 plus 2i. Now, don't forget, in some textbooks, mainly, or let me say mostly engineering textbooks, sometimes they can represent I as J. So it's another way of representing an imaginary number. So in this, if we are discussing with respect to addition, if we say Z1 plus Z2. Now, the concept here is that when you are adding two complex numbers together, you add real parts to real parts. You add imaginary parts to imaginary parts. So you just take it as the concept of you're adding like terms. So it means that if we're adding Z1, which is 6 plus 5i, plus our Z2, which is 3 plus 2i. So it means that we collect the like terms. The real part here is 6. The real part in the other complex number is 3. Now the imaginary part, we have 5i plus the imaginary part in the second, which is 2i. So 6 plus 3 will give us 9. I plus 2i is going to give us 7i. So just take a look at it as the concept of we are adding 5x plus 2x. That's going to give you 7x. So in this case, we don't have x. We are dealing with I. So let's assume that we are to solve z1 minus z2. We are subtracting these two complex numbers from each other. It means that this will give us 6 plus 5i. Now you must be very careful because this minus is subtracting the whole of this complex number. So you have to use a bracket. So this minus 3 plus 2i. So same parts, you subtract real parts from real parts, you subtract imaginary parts from imaginary parts. So this gives us 6 plus 5i minus times this is minus 3 minus 2i. So this is 6 plus 5i minus 3 minus 2i. So basically what this will give us is 6 minus 3 plus 5i minus 2i. So 6 minus 3 is 3. 5i minus 2i, that is going to give us 3i. So you can still leave this as 3 into 1 plus I. So, but basically the answer is 3 plus 3i. When you subtract those two complex numbers, you have a real part of 3 and you also have an imaginary part of 3. So that is what we have on addition and subtraction of complex number. And the last thing that I said I will discuss there is the quality of complex number. So for two complex numbers to be equal, for Z1 to be equal to Z2, it means the real part in Z1 must be equal to the real part in Z2, while the imaginary part in Z1 must be equal to the imaginary part in Z2. So it means that for, let's say for example, for A plus IB as Z1 to be equal to X plus IY as Z2, A must be equal to X and B must be equal to Y for these two complex numbers to be equal. So that's where we're going to end the tutorial for this particular session on complex number. See you in the next tutorial. Don't forget to like, share, and subscribe. And also, if you have a question, you can drop it in the comment section. I'll be more than happy to explain further. Thank you.